Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This is Sir Isaac Newton's formula, which is a very famous formula, which describes how things fall, objects fall. You might remember there's a fictitious story about him sitting under a tree and an apple falling on his head or something like that. The formula, I'll just write it over here again it's a little hard to see it when it's written this way in the problem. So h of t is negative 16 t squared plus 9.4 t plus 90. Okay, so you should recognize that this is a parabola because it's a quadratic equation here. And you should recognize that because the leading coefficient is negative, you're actually going to have a graph that looks something like this. This is time. This is the height. Now, in the world of math, we could have negative time, but in the real world, there's no such thing. So you could, if this tail bothers you, you can just erase it. Oops. I don't seem to be able to erase just part of it, but you can erase that if you wanted to. Another nice thing is you can see that h of 0, when you plug 0 in for time, this would be the starting height, which would be 90. So you know that this here is 0, 90. It's the y-intercept. And what they're asking for is at what time will it hit the ground, which would be this point here visually. So it's important to have this visual here. Now, if we were to do this by hand, what we would just say is 0 equals negative 16 t squared plus 9.4 t plus 90, and then we would use quadratic formula to find t. And I'll just remind you, or I should instead of x, I should say t, but we're all used to x. So it's negative b plus or minus square root b squared minus 4ac all over 2a. And then you would plug, you would just plug this in. Let me just change color. So this is a here, negative 16 is a. And then b is 9.4, and then c is 90. And you plug this in, and then you'd work it through on your calculator. Definitely need a calculator. You can see that they're asking for an answer carried out to 3 decimal places. And so you could just do it on your calculator using algebra here. You could put this equation into your calculator if you're using a graphing calculator. So this would be your y1 in a Texas Instruments calculator. This would be your y1. And then you could find the 0 here, the x-intercept here on your graphing calculator. What I did was I just put it into Desmos, and I'm going to show you that now. And I just think it's quicker and easier to put it into Desmos. Also, I think it's good for everybody to get used to using Desmos and get familiar with Desmos, because Desmos is going to be included and made available to you if you're taking the PSAT in October. And Desmos will be available on the regular SAT starting in March of 2024. So Desmos is an important tool. Unfortunately, when I download the graph, which you can see it starts at 90 here, and then we need this time down here, and unfortunately when I download the graph, this intercept isn't given to me. But online, all you have to do when you're working in Desmos is just click on that point. And when I click on that point, I get 2.684 comma 0, and that's what comes up when I click on the point. And so that's my answer, 2.684. So roughly 2.684 seconds after the flower pot is tossed, you can see it has a little bit of a rise here, and then it drops down. It was also given a little bit of a horizontal push, and so it drops down, and here it comes down to hit the ground at 2.684 seconds after it was tossed. So that's it. So that's all there is to it. It's a lot of computation if you do it by hand, hoping that your teacher would allow you to use an online calculator like Desmos or your graphing calculator that you normally would have at home. Okay, so that's it for this question. I hope my explanation was helpful to you, and I'll see you again next time. Bye-bye.